seemingly rather upset the Flat Earth community. Oh dear. They weren't happy because I stated they think the Earth is a flat disk, and apparently that's not the case. Apparently, real flat earthers, there's an ironic term for you, but real flat earthers don't think the Earth is a flat disk at all. Many even accusing me of outright being a liar and making it up to try and prove a point that doesn't actually exist. Except up until at least a few weeks ago, when I was still on Facebook, I was part of a Facebook group, a huge Facebook group called the Official Flat Earth / Globe Discussion Group. It has tens of thousands of members arguing both sides, those in favour of globe and those in favour of flat Earth. And I've debated with many of the flat earthers. Except when I was debating with them, I wasn't just saying, well, globe this and globe that. My arguments were more to pick holes in their flat earth theories. And so I would ask them how various aspects of the flat earth theories worked and what the flat earth models were. And they all gave different answers. I've spoken to people who argue that it is a disk with just an ice wall around it. I've spoken to people who argue that beyond the ice wall is just an infinite sheet of ice. I've spoken to people who say that beyond the ice wall are other continents and seas that we're not allowed to go to because only the Freemasons can go there. Most argue that there is the glass dome above us, but no one can even agree on how that is. Some argue that the dome covers just the bit of Earth that we know about around the ice wall. Others argue that the dome goes over the entirety of multiple continents or over the entirety of an infinite ice sheet. Some even argue that there's more than one glass dome. I've seen people argue that every individual has their own glass dome above them, or there are two domes to try and account for the fact that star trails in the northern hemisphere go the other way to star trails in the south. There are so many different ideas of the flat earth concept that it's impossible to say that this is what flat earthers believe, because flat earthers can't actually agree upon what they believe, because there is no one flat earth complete model. They can't stick to one. They end up changing the model to suit whatever particular debate you're trying to have with them, because there's no one model that fits all observations. They have to keep tweaking it and changing it to suit different observations, which then means that it doesn't work for other observations. But anyway, many of the flat earthers were saying that the content of my last video was just a straw man argument that didn't prove or disprove the flat earth, that it was completely irrelevant. Or there were some people who didn't even go that far and were just saying that obviously the earth is flat and that I'm a clown. So for every single person who I saw post anything like that, I challenged them to explain the moon and the observations that we can all make of the moon and how does that fit within a flat earth. And none of them answered it. Even the motor mouths who were going on and on and on, back and forth with conversations and debates, the moment the challenge of the moon came up, all of them shut up. I mean, let's just ignore the fact that we can't go to the top of Mount Kilimanjaro with a telescope and view the Himalayas, even though they are the two tallest points on Earth with nothing obstructing them. Let's ignore the fact that even as far back as World War II, naval gunnery had reached such a long range of firing that they were actually instructed to account for the Earth's curvature in their firing distances, because the distance that a shell travels will vary depending on whether you're shooting on a flat plane or over a curve. Or let's ignore the fact that in 1912, Robert Falcon Scott had left New Zealand and sailed south and wound up at Ross Island before trekking all the way to the South Pole, only to find the flag of a Norwegian expedition, which had already beat it there, despite the fact that they sailed from Madeira, near the Canary Islands, and sailed south, and wound up only a few dozen miles further along the Antarctic coast. Let's ignore all of that and everything else for the moment, and just focus on the conundrum of the moon. Ignoring whether flat Earth or globe, there are 5 observations that every individual can make about the moon. No, this is not hypotheticals or anything. This is stuff that you can physically go outside yourself, anywhere in the world, watch the moon, you will see these same observations. Observation 1, the moon is round. Now, I've never actually seen a flat earther try and argue that the moon is flat, to be fair. They all, I think, agree the moon is a ball. I mean, there's debates about how big it is, how far away it is, or what it is made of, but I think everyone agrees it's a ball. You can see it's a ball by the shadow cast of it. The fact that throughout the month, throughout the phases, you see that curved shadow around the edge of it, and it's always the shadow is backside to the sun. So observation 1, the moon is a sphere. Observation 2, at any given time of the year, from anywhere in the world, the moon always appears the same size. Now, the moon does change in size slightly throughout the year as its orbit gets maybe a bit closer or a bit further away, but on any given night, any given string of nights, you view the moon from anywhere on Earth, it always appears the same size. Doesn't matter whether you're up in the north, in the UK or Scandinavia, you're on the equator in Mexico, or you're over in Australia, the moon is always the same size all across the world. Observation 3 is that from any spot on the Earth, you watch the moon through the night, it will always stay the same size from your vantage point. You can see it come up from one horizon, transit all the way across the sky and down below the other horizon, and it stays the same size all the way across. Observation 4 is that despite it being a sphere, we only ever see the same face. Again, doesn't matter where you are in the world, only ever one side of the moon shows towards the Earth. Observation 5, despite the fact that we all only see one face of the moon, the orientation of that face changes depending on where you are viewing it from. More specifically, it changes depending on your latitude on the Earth. Now, that's not making assumptions about the shape of the Earth or anything there. That is just 5 observations that we all can make about the moon, and any model of the Earth has to be able to account and conform with those 5 observations. So let's try and fit those 5 observations into a flat Earth model. Observation 1, the moon is round, okay? That can fit. We can have a moon orbiting around the Earth, and it can be round. That's not a problem. Now, flat earthers say that the moon and the sun are both about 3,000 miles away. They don't buy this idea that the moon is 750,000 miles away and that the sun is 93 million miles away and that the sun is 400 times bigger than the moon. They think they're both about the same size and they're both about 3,000 miles away. So, we now have a spherical ball 3,000 miles above the equator of the Earth. Except the Earth is, well, we're not entirely sure how wide the flat Earth is. A spherical Earth is just shy of 8,000 miles across, which presumably if you stretch out a flat Earth, assuming they stick with that idea that the equator is 8,000 miles across, that then puts the entire Earth at about 15,000 miles across. Except that then means with the moon above the equator, on any given night, any country on the equator, the moon is 3,000 miles away from them directly up. And yet, a country in, say, the northern hemisphere, 3,000 miles away from the equator, seeing that same moon, the distance that they're viewing the moon from is over 4,000 miles. Which means they're seeing the moon about 40% further away than people on the equator. Which means that, given relative distance, the moon should actually be close to half the size when viewed from, say, the UK, than it should when viewed from a country on the equator. That doesn't conform. The only way to have no visible variation in the perceived size of the object like that is to have it much further away. If you put the moon 250,000 miles away, above the equator, To a country that is 3,000 miles away from the equator, that distance that it is seeing the moon from now becomes 250,018 miles, which is only a 0.007% increase. Not enough for us to perceive that. That observation doesn't work if the moon is only small and 3,000 miles away. It does work if the moon is 250,000 miles away. That then presents a problem, though, at least for flat Earth, because the sun would also have to be the same distance. You couldn't have a sun that's 3,000 miles away and the moon 250,000 miles away, because then solar eclipses just don't work. So the sun would also have to be at least 250,000 miles away, which would then mean that the entirety of a flat Earth would be lit all at the same time. Observation 3 kind of ties into observation 2 of this relevant relative distances. We can view that the moon stays the exact same size throughout the night. It crosses all the way across the sky. It doesn't change. Now, on the flat Earth model, the idea of the flat Earth is that the Earth is staying still and the moon is transiting above us, which means that if we see the moon on the horizon and it then comes up overhead and down across the other side, it's going from 4, 5, 6,000 miles away up and overhead to only 3,000 miles away, and then disappearing back off to 5,000 or 6,000 miles away. So the moon should actually change in size quite drastically. It should start very small, get bigger and bigger and bigger until it gets overhead, and then transit and go smaller and smaller and smaller. But it doesn't do that. It stays the same size, which means that it has to stay the same relevant distance away from the viewer, which means it would have to be traveling in an arc above one vantage point. But it stays the same at every single vantage point. So it would have to be staying at the same distance away from every single vantage point at the exact same time, which again does not work for a moon that is only 3,000 miles away. Not only that, we have the viewing angle to consider as well. On a flat plane, any object above that plane would always appear to be above that plane, especially one 3,000 miles above that plane. Even if we take a worst case scenario here and say the moon is 3,000 miles above the equator over South America, and you're standing on the ice wall on the opposing side of the Earth, basic trigonometry, you can see that the viewing angle for the moon is still 14 degrees above the horizon. So even worst case scenario, if you made it all the way to the edge of the world, the moon at its furthest point from you shouldn't be anywhere near the horizon, much less going below the horizon and then staying below the horizon for half a day before reappearing near you again. Now, some flat earthers have tried to argue that it's the opacity of the atmosphere that causes this illusion, whatever the fucking hell any of that means. If that was the case and there was some fanciful magic going on that would make the atmosphere magnify the moon to the point of about doubling its size at the horizons but not overhead, then whenever I see a plane travel from the horizon, fly overhead and disappear off into the distance, it should also remain the same size. It should appear as big to me on the horizons as it does directly overhead. I know, even you can wrap your head around this, but it doesn't. So atmospheric trickery doesn't seem to fit into that either, unless the atmosphere is very selective of thinking I'm going to magnify the moon today, but I'm not going to magnify a plane. Observation 4, we only see one face of the moon. Again, anywhere in the world, we only see one face of the moon. Now, if the moon was 3,000 miles and orbiting the equator, then when you're viewing it from the northern hemisphere, you would see a completely different vantage point than the southern hemisphere. You would be looking at opposite sides of the moon. Now, I've seen flat earthers try and argue this away by using the analogy of sticking a picture to the ceiling and looking at it from opposite sides. But these people seem to overlook a small fact that the moon is not a flat picture stuck to the ceiling, it's a three-dimensional object. So if I stick a three-dimensional object to the ceiling, from one side, I'm viewing this side. From this side, I'm seeing a completely different face of it. And observation 5 basically ties into the previous 4 observations. We only ever see the one face. The face changes orientation depending on our latitude. Now, it doesn't work on a flat Earth model because it basically ties into the previous 4 observations. The moon can't be 3,000 miles away and only very small, because you wouldn't see different orientations of the same face. You would be seeing completely different faces depending on your latitude. So the moon would have to be 250,000 miles away. But with the moon then orbiting 250,000 miles above a flat Earth, it's just circling overhead, and we're all on a flat plane, we're all seeing exactly the same thing. The only way that we can see different orientations of the face of the moon that we have no control over is if the person's vantage point is a different orientation, which only works on a globe. So the observations that we can make of the moon don't fit to flat Earth models. You can make it account for some observations, like moving the moon much further away, but then that means that your observations of the moon versus the sun don't fit, so you have to move the sun further away. But then the observations that we make of the sun versus what it is able to light of the Earth at any one time then don't fit. Every time a flat earther moves the goalposts of the flat Earth model to try and
So tell me, Neil, is the Earth flat?
We have video from space of the rotating spherical Earth. The Earth is round.
Thank you for joining us on this episode.
What's odd is there are people who think Earth is flat,
Right.
but recognize that the moon is round. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and the sun are all spheres, but Earth is flat. That's not, something doesn't square.
Something doesn't jive, right?
Okay. Plus, in my latest book, ooh, did I just plug my book?
Wait, your latest book is called Astrophysics for People in a Hurry. What? We just happen to have a copy right here.
No, it just happens to me. I swear we didn't plant the book. I have an entire chapter titled On Being Round. And it's an exploration of how all the laws of physics and the accounting of energy as processes unfold in the universe, how that conspire to make things round.
So it favors the sphere.
Favors a sphere, yes.
Right.
And if something is not a sphere, it's a little bit flattened, you can ask what flattened it, and you find out, oh, it's rotating real fast.
Right.
So then it gets a little flattened because of that.
Right.
And so almost everything in the universe is either spheres or slight distortions of a sphere for some other thing that's happening to it. I mean, we can just see how the universe favors spheres.
So it's nature.
Right.
Basically,
Nature.
the universe.
In all fairness to the people who want a flat Earth.
Yes, let's be fair to those people.
Okay? In Columbus's day, there was surely a flat Earth contingent. Okay?
Yes.
Columbus predates the era of experimental checking of any idea you might have.
Not a lot of peer-reviewed studies back in the day.
Back in the day.
Back in the day.
Back in the day.
Kind of just like...
You just say whatever you
Right.
felt.
You know what? I believe that elephant poop will cure cancer.
There you go.
That's right. Wrote a paper about it. Like to read it? Here it is. And you're good, right?
Right. So it wasn't until Francis Bacon, Galileo, 1600s, where the idea that if you're going to say something and you think what you're saying is true, then no matter how obvious you think it is that it's true, you should still test it.
Gotcha.
There could be something fooling you in one way or another. So if you want to say Earth is flat, then, for example, lunar eclipses. What's a lunar eclipse? If your face is the brilliant sun,
Thank you.
and this is Earth, and the moon is over here, the sun is always casting Earth's shadow into space. It's always there no matter what.
Right.
obviously, okay? It's just a shadow.
It's a shadow.
The moon
It's just a shadow
occasionally...
shining on blackness.
Yeah, a shadow in darkness.
A shadow in darkness.
So the moon occasionally passes through that shadow. And if you see the shape of Earth's shadow on the moon, it is always round. Always round. If Earth were flat, sometimes you get like a flat shadow.
Right.
And we've never seen a flat shadow.
Right.
In fact, it is a segment of a arc of a circle, no matter the orientation of the moon and the sun. And the only thing that makes a perfectly circular shadow
Would be something that's perfectly circular.
perfectly spherical.
Spherical.
Yes. So the only thing that makes a perfect circle shadow every single time is a perfect sphere.
Right.
Okay? No matter what angle
matter
you
where
shine.
you're shining.
Whereas a disc, it would only make a perfect circle if you lined it that way.
Right.
And then
you have to look at the face of the disc in order to get the circle.
the circle. If
you-
any other angle, you get other shapes.
something of another
The
shape.
Greeks knew this.
Right.
All the lunar eclipses they said, oh my gosh, we must be in a round Earth. This is thousands of years.
Before
2,000 years
Columbus.
before Columbus. Exactly. So now if the Earth is round, how big is Earth? You might want to check for that. There was a famous experiment conducted by Eratosthenes.
Eratosthenes.
And the two cities in the old world, and one of them, they knew that at 12 noon on a particular day of the year, that the sun was directly overhead and you could see the bottom of a well.
Oh, okay.
You don't run around looking at the bottoms of wells.
No.
Because the light doesn't take, it's just, no.
Doesn't get down there.
Doesn't get down there.
How can we use this observation to see if Earth's surface is curved? We needed another well. Turns out we can't see the bottom of both wells at the same time. What might explain this? Well, there are two possible explanations. First, we could have a flat Earth with the sun that's small and close by, so that the light hits the second well at an angle. Or second, we could have a curved Earth with a sun that's big and far away, so that all the light comes in parallel, but only one well at a time is lit all the way to the bottom. Turns out with just two wells, there's enough wiggle room for both explanations to fit our observations. Eratosthenes only had two wells, but what if he had added a third? With a third well, it doesn't matter where the sun is. No flat Earth model can explain the angles of all three shadows, but the spherical model explains it all three angles, with ease.
And to do this experiment, you got to measure the angles. Greeks had the angles.
Yeah.
Okay, in fact, geometry translates to Earth measurement. So one last thing, which should be obvious,
Okay.
if you pay attention and think about it. If you send a ship straight to the horizon,
Right.
eventually it begins to disappear until it's no longer visible beyond your horizon.
Right.
And you should ask yourself, what kind of surface would produce that result?
The
If
ocean,
it's
the ocean has a ramp. It's like a parking lot. The ocean has a ramp.
And it's an elevator.
Yeah, it's
at
an
the end.
elevator. And, you get to a certain point, and they're just like going down.
Seafarers knew this.
Right.
And so, however flat they would have imagined the Earth to be, they couldn't have accepted it to be completely flat, because otherwise you would never not see the ship. Okay. Also, if I just tell you, Chuck, walk due east, okay?
Right.
And don't ever stop.
Right.
I just turn around my chair and face this way, and eventually you're going to come back.
Right. And you'll probably be about 150 years old. Because I am no Forrest Gump. That is how long it would take me to run the Earth.
For me, the fact that there's a rise of flat earthers is evidence of two things.
Okay. One.
One, we live in a country that protects free speech.
That's actually kind of awesome.
And two, we live in a country with a failed educational system.
Ooh, that one hurt.
Our system needs to train you not only what to know, but how to think about information and knowledge and evidence. If we don't have that kind of training, you'd run around believe anything.
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 And if you're interested in learning more about the Earth, the Sun, and how the fact that we're hurling through space at, what is it, 17,000 miles per hour? Is that what we're going?
Did you just pull that number out of your...
I did. You know where I pulled it from. So you should consider all of this and consider checking out Brilliant. Whether you are an adamant defender of the Earth's curves, Or a professional scientist or a lifelong learner, Brilliant helps you master concepts of math, science, and engineering through solving fun, challenging problems. And you can sign up for free to get access to weekly challenges. And as a bonus to Star Talk viewers, anyone up to the 19th prime number that goes to brilliant.org/StarTalk will get 20% off the annual subscription, which helps you think like a scientist through guided course material and the ability to track progress with stats and extra practice. If you like what you see and you want to watch more videos from Star Talk, hit the subscribe bar and click the little button that gets you notifications every time that we put up a video. And don't forget to like and comment below with a topic of your own that you've been dying to get to the bottom of. All right, so hey, for those of you who are flat earthers, we say it's okay as long as you don't run NASA. And for those of you who are Greek philosophers and mathematicians, Neil will tell you what they would tell you, which would be?
I don't know Greek, but if you could translate ancient Greek into English, they would say, keep looking up.
Now then, most of us have spent our entire lives thinking that the Earth looks like this. But you can forget about that because the Earth, in fact, well done, nicely caught, looks like this. This is what it is. It's flat, and it has a, just like Game of Thrones, it has a big ice wall.
Well, Mark Sargent is one of the leading voices in the Flat Earth movement, and he believes it's time that we all woke up and realised that we actually are living on a flat disc.
Well, Mark joins us now.
Welcome.
Good morning, Mark.
Welcome.
I mean, obviously, there are thousands of questions,
Yes.
which I'm sure you've been asked 1,000 times.
A few, yes.
Yeah, so we believed for many years that the Earth was flat, and then science comes along, and discovery comes along,
Right.
and we think, right, okay, now we can see that it's actually round.
Sure.
We've seen that it's round.
Sure.
So how come it's not?
It's not because we can't prove it's a globe. Everything that we've, in fact, it starts out with everybody that's in the flat Earth community starts out looking at the globe saying, can you prove it? Can you prove the globe, especially without using NASA? Because it's not that we found out that the world was a globe back in 1972. We knew for 5 centuries. So that's how everyone starts. You try to prove it in a court of law.
I flew in Concorde, and I was lucky enough to fly in Concorde, and you get up to 65,000 feet, and
Yep.
I could see the curvature of the Earth. That was proof to me. How come that wasn't true?
And yet I could show you weather balloon footage from 120,000 feet, and it's absolutely tabletop flat. And Neil deGrasse Tyson, the world's most famous scientist, no offense to Brian Cox, he'll come out and tell you, no civilian will ever be able to see the curvature of the Earth.
So is he lying?
No, I'm not saying that you're lying. I'm saying that you wanted to see the curvature. There's a big difference.
But don't you want to believe that it's flat? You have
No.
more proof. I have more proof than you do.
I would challenge that.
Well, I've got footage here that's direct from the space station. And that's live pictures from the space station now.
Right.
That's all alive.
Again, started from the American military. Yes, absolutely. I'm saying it's worse than that.
So what is that then? What am I looking at if I'm not looking at live pictures?
You're looking at CGI, nothing more. Something that started out very simple back in the 1950s and advanced till today.
So I'm a bit of a space nut.
Sure. Sorry.
And so no. I mean I'm very happy with that.
Right.
And I've got the app on my phone which has got where the space station is right now. And I have in the past looked at those live pictures.
Yep.
And I have seen where the space station is and thought, right, it's coming over me now. And so I have watched the space station. You can see it as that light. It doesn't blink, doesn't flash, goes over as a solid light. And at the same time, I've looked at my laptop and I've seen where I am.
Yeah. Oh, I'm not saying there's something up there, no question. Is there a vehicle that could be the ISS up there? Yeah. Are there people inside it? No. Not a chance. And you can look at the interior footage and the production value is horrible. I challenge anybody. We've got
I've interviewed, both of us, we've interviewed Tim Peake from this sofa.
I know. And
So what was I doing? Who was I talking to? Where was he?
You were talking to a military officer, nothing more. I talked to Terry Virts, American astronaut. And look, they're all, you gotta remember, everybody that goes up there are high-ranking military. They start out at
But
colonel and go...
Why would he bother?
Why would you bother faking it?
Yeah, why? What's the point of faking it?
Well, that's one of the bigger questions, which is why keep this thing a secret? And we're talking about
No, but why fake it?
because if you don't fake it, eventually the private industry is going to get involved, and then they're going to find out on their own. This is
And why that would be bad? Because
if you don't keep this thing a secret. Remember, we're talking about something that was discovered back in 1960. The public wasn't ready in 1960. They just weren't. Their potential academically, economically, religiously, chaos, potentially. And so they weren't going to take that chance.
So pilots are involved in this?
No,
They
not
don't
at
know?
all.
They don't know?
Pilots, scientists, none of those people. I have astrophysicists, Brian Cox. None of them have anything to do with it.
Okay, so all of those people,
Right.
Every NASA science, everyone who's scientist, everyone who's ever been involved in at any stage in any space program, whether it's industry that launches satellites, the various people that launch those satellites,
Right.
everyone that's ever worked on a space shuttle or the Apollo program,
Right.
they're all
No, it's
pointless?
No. I mean, jobs are created. It's compartmentalization. I mean, it's no different. Look, generals know the battle plans, but most of the officers below them
Were
don't.
the Apollo, those massive Apollo...
We've been to the moon, right?
Were those Apollo rockets that went up into the air, did they go?
They didn't go anywhere. They just went off into the ocean and ditched. Again, I'm an American. Look, we're taught, rah, rah, go team, wave the flag. And so it's tough for me because I love the American space program.
So you flew in a straight line to get here?
I did fly in a straight line to get here.
Yeah.
Yes.
And,
Over a level playing
you've
field.
got this, so we've got a dome over the top?
Yeah. So let me do this real quick. So the globe that you threw away, what we're talking about is we are all brought up, taught that we live on this tiny little rock that's covered in a little bit of water and smoke. We're flying through this impossible vacuum of space. We're saying that we live on a flat, enclosed world that is you're basically living in a big soundstage with walls and a floor and a
The
ceiling.
Truman Show.
The Truman Show. Yeah, very, very, very similar. That is so big that even our best and brightest didn't figure it out until about 1960. And when they did decide to keep it a secret, the really, really short version is you don't live on a globe. This is what it looks like on the outside. That's what it looks like on the inside. There you go.
So why don't we just fall off the edge?
For the same reason, the space asteroid question. Yeah. So for the same reason why you don't fall off the edge here. Antarctica is the only continent that doesn't look like anything else. All the other continents in here look perfectly fine. Antarctica, though, and it's not necessarily an ice wall, it's just Antarctica, this really, really, really high continent.
So you're saying Antarctica goes all the way around?
Yep.
So where's the
Antarctica.
North Pole?
North Pole's in the center. North Pole's in the center, South Pole doesn't exist. Compasses don't work down in Antarctica. Most people don't talk about that. The Antarctic Treaty says that no corporation in the history of the world can set up shop down there forever.
What's outside?
That's a tough one, isn't it?
Well,
I mean, because it
you
could
have
be.
no clue.
Well, I mean, if you can't get outside, you're not going to know for sure. But I mean, I don't think, my personal opinion is this isn't a one-off. There's not just one of these. There's more.
So we've got a picture of what you think what it's.
Oh yeah. That was made by one of our people, and it's a great option. I love it.
Have they been there? Have they seen that?
No, of course not.
Okay.
So
There's
are
a
they
hole in the
just
wall there.
making
There's a
it
hole.
up?
No.
Like, are they-
There's a hole in the wall.
Yeah.
So can you go through that and go to the other places?
Again, Flat Earth opens the minds of people. Most of the Flat Earthers will stick with something like this. But, other Flat Earthers, I'm not going to knock them. It opens minds.
Okay, but amongst your people,
Yes.
amongst your flat earthers,
Sure.
you argue amongst yourselves as well.
Like the
And
Scottish
actually,
Highlands, we argue.
You have been accused yourself as being sort of a member, I think, of Warner Brothers or something. You're making this up.
Government agent, yeah.
So, I mean, aren't you just all turning on yourselves? Like,
No,
you can't believe anything.
No.
Ever. Not even your own.
At the end of the day, again, like the Scottish Highlands, no offense, but they can all agree on one thing: they hate the English. That's the same sort of thing here. We disagree on so many of the finer points here, but at the end of the day, we all agree on one thing: that is not a globe. And you can absolutely you can hammer on the globe. Everybody starts out hating flat Earth, and everybody tears down the globe themselves. That's why we have a 99% retention rate.
Do you not believe any proof in anything?
No, I believe in proof in things.
Okay.
But
in which case, I've got to ask you.
Sure.
That we obviously, those of us who believe that the Earth is round.
Right.
There are lots and lots of things that would help us to convince ourselves that the Earth is indeed round.
globe, by the way.
The globe. Yeah.
I mean, technically, this is round.
Okay. And flat. And so, what proof do you have?
Got it.
No one has ever been there.
Got it.
No one has ever taken any pictures of the ice wall that surrounds it.
Exactly.
So, no one can get anywhere near. Why can't we go there? Why can't I?
Oh, the Antarctic Treaty. And you can go there if you want to spend, I think it's like 12,000 pounds. You can go to the edge, one of the peninsulas, and get your picture taken with penguins.
No, I want to see the wall. Well, I know.
Well, I mean, the wall itself
Africa's
just
been to
extends for a long. You can get to the Antarctic coastline. That's not a problem.
Yeah. I want to go to the wall.
Well, you're going to go all the way in here. No, the Antarctic Treaty forbids it. You cannot go there. It's locked down. It's the only unbroken treaty in the history of treaties.
So
How do you know
every
that?
country in the
Oh
world.
no, it's not secret information. None of this stuff is secret information.
But where are you getting that information?
What, the Antarctic Treaty? It's public domain. I mean, it's a PDF. In fact, I gave it to your producer.
But the
It's on a
Antarctic
flash drive.
Treaty is about limiting the stripping of resources.
It's all corporations. Every corporation in the world, no one can set up shop there. And it's also the only piece of real estate in the world that's not owned by anybody. A little strange, since we're fighting over real estate all the time. But no, I mean, stripping of resources, in a treaty that was built in 1959, environmentalism wasn't even a word back then.
Do we communicate with anyone out there? Is there any trade between the two places?
I don't know. Couldn't tell you that. To your proof questions, and I know we don't have a whole lot of time left. Sorry, let me give you the 5 bullet points that I gave a Georgetown physicist, and he folded like a card table almost immediately. I put this challenge out to Brian Cox, Neil deGrasse Tyson, Michio Kaku, any of these guys. First one would be long-distance photography. Curvature of the Earth is 8 inches per mile squared. We eventually should not be able to see over the hill. We should be a hill. It should be gone. HD technology has changed that. Now we can see things way, way further. There's some wonderful work being done by Nathan Oakley and some UK teams where they're actually seeing a horizon behind oil platforms at 10, 15, 20 miles. Gravity versus the vacuum of space. Gravity's holding things down, right? That's gravity, no problem, right? You make the upper part of this a vacuum chamber, you pull a cork, everything's gonna rush upstairs. Well, why, when you go outside, why isn't the air outside rushing into space? You can't, the atmosphere, why doesn't it go into space? Can't say gravity anymore, because gravity didn't hold the air in this room for that little test. Third, the moon eclipse is too small. The moon eclipse is 70 miles wide, and the moon is 2,000 miles wide. We never see that in nature. The moon eclipse we say the moon is about 70 miles wide. Fourth would be the moon temperature. That's a spooky one. I didn't even know that till about two years in, which is the moon generates a cold light, which is warmer in the moon shade than it is in the moonlight. If you magnify moonlight, it gets even colder. It's generating a cold laser light. It doesn't even make sense. And the last question, which is the Van Allen radiation trap question, which is, are the Van Allen radiation belts deadly? Yes or no? If they are deadly, then how'd the Americans get past it with no shielding whatsoever? Remember, the only thing that can stop radiation is gold, lead, and a whole bunch of water. They went with aluminum and plastic. Nobody died, nobody got radiation poisoning, no one even got cancer. There's still 5 of them walking around today. If you say yes, then why does NASA have this wonderful video, Ryan trial by fire, saying, oh yeah, we can't send any capsules into space because we haven't solved the radiation problem yet?
Well, maybe that's because you've got to go closer when you go to Mars and it takes longer and there's more exposure, perhaps? I don't know.
Maybe.
Yeah, well.
Maybe.
He says.
Well, no, I'm not going to shoot it down. That's a better answer I've gotten from a lot of people. Sorry, go ahead.
NASA say, we've known the Earth is round for more than 2,000 years. The Earth is not a perfect sphere because the force caused by the Earth's rotation, north and south poles are slightly flat. Earth rotation, wobbly motion, and other forces are making the planet change shape very slowly. But it is still round. That's say NASA, but you say that they're in on it.
Yeah.
I say, listen, of all the things that are going on in the world, of everything that's happening, I think we'd all probably cope if someone said, actually, it looks like this.
I think we would too.
Okay, all right, fine.
I absolutely agree with you, which is why I think it's being let out. I'm not.
Stop spending all the money on CGI and
I agree.
space products and projects, and let's build some more hospitals.
Absolutely.
I think we can all cope with it.
I agree. 1960, I don't think we were ready. 2020, I think we are.
Let's go there and see what's like on the other side. There might be nicer places to be. It could be a good holiday destination.
I'm with you.
Yeah.
We could put it on the spin to win.
I think we're ready to know. Tell us.
Thank you. Thank you. Fascinating.
The Earth is flat. Why do you say that?
The evidence that we've seen doesn't suggest that what we've been told is true.
What evidence
Such
have
as?
you seen?
Well, I personally have been to Lake Balaton with FE Core, and we've actually done a laser test from one end of the lake to the, well, didn't do the full lake because it's massive, but we did a 12-kilometre test, and we could actually see the laser from one end to the other. And since then, the guys have actually produced a 40-kilometre laser test.
So this guy with a laser debunks all the pictures.
No, it's not. That's the only thing. It's just an example of some of the experiments.
So, Darren, you were sceptical at first, weren't you? So you thought...
I think it's right to be sceptical about alternative views, but what we never are is sceptical about the mainstream view that we're told since we're children. Over and over again, it's programmed into us.
So what finally convinced you, then?
Well, it took me 6 months. I was sceptical for the first 6 months. And there are a couple of main things. One is water always finds level. So in our own experience in natural physics, you have a cup of tea or a swimming pool or a lake, water is level. But we're led to believe that, well, the Earth is supposed to be 70% water, so at some point water starts curving around a ball. Now, obviously, the answer to that is the magic of gravity.
Yeah.
Now, I believe gravity exists, but only as an effect, not as a cause. So science itself has never proven gravity as a force itself. What is proven is 9.8 meters per second squared is the near constant rate of acceleration towards the Earth all over the Earth.
What is happening here?
That's what I'm saying. We don't know, and science has never proven that as a force. Obviously, they have proven it is observable science that things accelerate at the same rate, yeah? But
And that we're stuck to the ground.
Nobody knows what is actually causing it, and scientists themselves will tell you.
So Sir Isaac Newton got that wrong, did he? Did he just get that completely wrong?
Well, I don't think he particularly got it wrong. I think we're told a lot of truths, but possibly not full truths.
What about someone like Brian Cox? Is Brian Cox a liar?
I mean, you'd never call somebody, you know, outright a liar. But is he mistaken? Absolutely. But are most of the world, or 99%, you know, of people mistaken? Yes.
This is what Brian Cox had to say about the flat Earth theory.
Put aside the fact that we've taken photographs of it, and you can see a horizon. And not only can you see the horizon, but you can see things move behind the horizon or in front of the horizon, depending on the height that you choose to look at the things. You see, I'm lost for words. It's probably the most nonsensical suggestion that a thinking human being could possibly make. It is drivel.
So that's from a scientist.
He was, and he said something very interesting there. He said it's nonsensical, and we say that's actually not true. What our own senses tell us is that the Earth is stationary.
But nobody's fallen off the edge of it.
Nobody has fallen off the edge.
At what point do you fall off the edge?
Can I just respond to what Brian said there? He said things disappear behind the curve, and one of the main reasons why we believe that the Earth is a fixed stationary plane is because things aren't disappearing as quickly as they should be. We can see cities and mountains and islands 40, 60 or 100 miles. The world photography distance record is 273 miles, right? And we can see the tips of the Pyrenees from the south of France, and you shouldn't be able to see it.
You can't see the base of them.
Well, of course not.
Because the Earth is round.
Not because the Earth is round, and because of perspective, and because of the way light works, and because of the way our eyes work.
We interviewed on it. One of the highlights of my career, actually, was interviewing Major Tim Peake up in space on the International Space Station.
Right.
Now, he brought in his beautiful book. You see the curvature of the Earth. You very clearly see that it's a circle. So are you telling me that this interview with him, I'm talking to somebody that's just made that up or wasn't actually there?
Yeah, he's not.
Can I just...
He's not in outer space.
Can I just...
Where is he then?
In a Hollywood studio type
Not necessarily
environment. Maybe here, but maybe where we are now.
But, so you're saying that Tim Peake is a liar?
Well, I mean, if you look at Tim Peake and people like Neil Armstrong and all the astronauts, they're all military guys. If you look at them, they're all military. They're not scientists.
No, they're not. No, they're not. 230 individuals from 18 different countries have visited the space station. They were not all military. Some were teachers. We've met some of them ordinary people. Are all 230 people liars?
Can we just end this debate by saying...
No way can we.
We've got a beautiful globe over here.
It's been going for quite some time.
We've got a fantastic globe over here, right? I'm going to ask ISS, NASA, whatever, to zoom out of the Earth right now and show us planes, zoom to show people walking upside down. Let's do that, and we will... I'll come back here and apologise.
The space station can't zoom out to 230. It can't zoom out to beyond where...
So can we get a probe out? Can we get a probe out?
We've done that.
It's only 250
of the whole Earth, and showing aeroplanes flying upside down underneath the globe? Can we see that?
All we see is CGI.
There are apps that can show you that.
What, aeroplanes flying upside down?
Live.
No.
Wow.
Yes, there's the live positioning of all the airplanes on the world
Right,
that
but
are on
but
there.
that-
Can you answer me a question? Because I have personally seen with my own eyes the curvature of the Earth.
Is he lying?
Is it the circle
he's a liar.
vision of
He's
your
not a liar, though.
Is it the circle limit of your sight? Because obviously the limit of our
I was one of the
eyesight
very, I was very,
is a
very
circle
lucky,
around you.
and I went on Concorde.
Okay.
So I was very lucky I went on Concorde. So that's 60,000 feet. You could clearly see the curvature of
What's
the
the
Earth
shape
from
of the windows?
Concorde.
Actually,
Oh,
science.
it was the shape of the window.
No, I said no. I didn't say that. I said what was the shape of the windows? Is what I said.
Like an oval?
Scientists themselves
oval, right?
tell us that you have to be 50 miles up to be able to see the curvature of the globe. A plane, an average commercial plane, travels at 7 miles, which is around 33,000 feet.
Which
35,000
Concorde
feet.
wasn't.
You
What's
were
that?
about 10 or 12 miles, so it's still, again, way below what scientists themselves tell us.
Oh, I've got
you need
so
to be
many
able to
questions.
see.
We're going to have to end this. I'm really sorry. I really want to ask you, but hold on. We will. We can continue. But we asked a poll. You've got a long way to convince our viewers,
Absolutely.
I'm afraid. Do you think the Earth is flat? No, say 94% of you, but 6%.
Probably about right. All I'd say is go research it for
Research
yourself.
for
There is
yourself.
a wealth of
don't
material
trust us.
online.
All right.
Have a look
We're
for
living in the
yourself.
age of technology. There's no excuse anymore.
Yes,
All right,
absolutely.
thank you. Although the
And if
Greeks
you,
saw the shadow on the thing, they didn't.
If you are
There's an explanation
interested,
for that as well.
Yes, we are.
There is.
if you are interested, the space station is currently off the coast of New Zealand.
Or is it?
And
Just go to the moon. Yeah, there'll be a day when AI takes over and it'll make us their pets. Whatever God is not luck. Hi, I'm Neil deGrasse Tyson, your personal astrophysicist, and I'm here at Penguin, UK, to answer some of your deepest, most pressing questions. Does that work? Yeah. Okay, good. Have you really thought about what it would take to fake a moon landing? Because the rocket did launch. We all saw the rocket launch, okay? So there's hardware there. They're like office buildings, blueprints for the design of the Saturn V rocket. The hundreds of engineering hours that went behind this and the records of those designs. If you wanted to fake the moon landing, you would have to fake all of these documents. And it just seems to me it's way easier to just go to the moon. Has anyone considered that? Just go to the moon. That's easier than faking all of this. So, no, yeah, we went to the moon. So climate change will not make Earth uninhabitable. Climate change will make Earth a living hell. In fact, I live in New York City, where in our harbor we have the Statue of Liberty. And there she is holding the Declaration of Independence. And in her left arm and her right arm is the torch. If you melt the water ice that's on land, the ocean level will rise to reach her left elbow. So that takes out all of New York City. And basically every other coastal city that we've spent thousands of years building since the dawn of civilization. So life will be very, very different. So the way I look at it is, there are people who want to colonize other planets, give us an escape route. We trashed Earth, let's move elsewhere and hope we don't trash that. Well, there aren't many places to move. You'll vaporize on Venus, so you're not going to Venus. Mars rotates once every 24 hours. That's kind of interesting. It's tipped on its axis, as Earth is, which means it has seasons. It has polar ice caps, the way we still do at this moment. And there's evidence of running water on its surface. So there's a chance we could terraform Mars. My favorite word of the past few decades. You turn something that's not like Earth into something that's like Earth. So then you just move there. So here's the catch. If you have the power of geoengineering to turn Mars into Earth, then you have the power of geoengineering to turn Earth back into Earth. I don't know if God exists. Deeply religious people are certain he exists, he or it. There are ardent atheists who are sure God does not exist. My posture is, particularly in the monotheistic traditions, that God is typically described as being all-knowing, all-powerful, and all good. Yet I look back through history, in particular there was I can choose many examples, but a famous example is an earthquake in Lisbon, Portugal. When was it? 1755, somewhere around there. 80,000 people died. By the way, that earthquake took place on All Saints' Day, in the morning, when most people, Lisbon, one of the holiest cities in Europe, most people were in church. Churches were the largest structures of the day. If you have an earthquake, what's the first building to collapse? It's the ones that are the largest, the most susceptible. So, people died in churches. Then, there's a tsunami that basically wiped Lisbon off the map. Either God is not all good, if we define good as being in the interest of your health and longevity, that's a pretty simple definition of something that's good for you, or God is not all powerful. But it's not clear whether God could be both of those at the same time for that event. So I take issue with what many people say God is. But there are other kinds of ways to think about God. There are enlightened religious people who would say God is the manifestation of the laws of physics in the universe. I don't have a problem with that. But is God the person who tells you who you should mate with and on what day you should eat what kind of food and is that your God? That's different from this other one that maybe just sort of put the universe into place. So I don't really concern myself much with it unless someone finds a way that any understanding of God can give me insight into making another discovery. And that hasn't happened yet. There are many people who will see things happen to them that are in their favor. They say, oh, someone's looking over me. So that's a fascinating phenomenon when that happens. And when you analyze those situations, what you find is that we as humans simply have a profound inability to understand statistics and probability. It's really that simple. And it's a quick experiment. Line up 1,000 people and give them a coin and have them flip the coin. And if whoever gets tails, tell them to sit down. So it's about half. So 500 people left. You repeat it. 250 people left. 125, 60, 30, 15, 8, 4, 2, 1. It's a thought experiment. So approximately half the people sat down every time they flipped the coin. Half of them get heads, half get tails. There's one person that's standing at the end. That person flipped heads 10 consecutive times. So who does the press go to? The press goes to that person and say, how do you feel about this? Well, I felt that heads energy about halfway through, and I kind of knew I was going to win. I saw heads on the thing. And did they interview anybody else who might have felt exactly the same way but didn't flip heads 10 times in a row? Because they're on their way home now. They're not there for the interview. So we're thinking that this guy had some kind of clairvoyance about his fate, or that he prayed or whatever. And so, whereas every time you do this experiment, basically, somebody flips heads 10 times in a row. And so we don't know how to handle coincidences or things that are rare for you, even if they're common in total. So, whatever God is not luck. We can demonstrate that mathematically. Personally, I'm not all that worried about artificial intelligence and robots taking over the world. But almost everyone I know who's an expert in it, they're worried. They're all worried. I'm reminded of Ray Bradbury, author of many great science fiction novels about Mars and other stories. He was once criticized. Someone asked him, Ray, why do you have all these apocalyptic, futuristic stories? Is this what you think we have in store for ourselves? And he says, I don't write these because I think that's what our future will be. I write these stories so that you know what future to avoid. And I said, ooh, that's deep. So the fact that we've had our share of films that show computer intelligence taking over, I think it spooked us. And a little bit of spooking is a good thing. It means you'll move forward, you'll step lightly. But here's my reasoning for why I'm not as afraid as AI experts. Every manifestation of computer ability that has arisen has been parsed into some task or set of tasks that we previously had undertaken, and now the computer does it. So we used to build cars on an assembly line. Now robots build cars. And cars are better than they have ever been. People think of robots that'll run around and they'll have all this high intelligence. Well, go back 40 years ago, 50 years ago. People were imagining robots, humanoid robots, and then the robot would then drive your car. No, not today. The car is the robot. So the idea that you would have what they call general intelligence, some kind of entity that can learn anything and do it better than any of us, I just don't see that as the direction things are headed. We'll have tasks, we'll get some really good computer to figure out how to do it better than we can, and then it happens. So I'm not as worried. But if the concerns of AI experts are real and we need to heed them, yeah, there'll be a day when AI takes over and it'll make us their pets. We should all behave, learn how to behave better, because the day AI takes over, they're going to pass judgment on whether humans should continue or not in this world. They're rendering all these other animals extinct, they're destroying the environment, they can't even be shepherds of their own fate. So, yeah, they'll just exterminate us all. Have a nice day. Yeah.
The fact that black holes exist, I think, the gravitationally completely collapsed objects that distort space and time so much that even light can't escape. I still think it's mind-blowing that according to Einstein's theory alone, time ends inside a black hole. I'm Brian Cox, and I am here to answer questions from the Honesty Box. Explain quantum mechanics to a child. So, quantum mechanics is the base theory, we think. I think people tend to think of quantum mechanics as something that applies to atoms and electrons and particles, but not to us. And that's not right. So quantum mechanics is the theory that describes everything. The point is, though, it produces, when you look at big things, it produces behavior which can be more accurately, or more usefully, not more accurately, but more usefully described by things like Newton's laws. It is necessary to understand quantum mechanics to understand how a transistor works, for example, or how a laser works, or how, of course, a nuclear reactor works, or the sun works. So it's not just a theory that's a theory of little things bouncing around. It's a theory that's necessary to understand a lot of things that we take for granted today. And it's an unusual theory. It's strange because it's got probabilities in it. And that was actually, it was Ernest Rutherford, actually, so famously got the Nobel Prize at Manchester for discovering the atomic nucleus. But he pointed out that in the late 1800s, early 1900s, when we start looking at radioactivity, you see that radioactive decay is a probabilistic process. So it means that given something like a uranium nucleus, you can't tell, even if you made 100 uranium nuclei at the same time, you could just make them, then you can't predict when any one of them is going to decay away and emit some radiation. Basically, it's probabilistic. And so that idea was shocking to people, that it appears that the world is not like Newtonian clockwork. So I would say quantum mechanics, my explanation is it's a weird theory, it's a kind of probability theory, and but it's the way that things actually are. Can you explain the scale of the universe? No. So you can give the numbers. So the nearest large galaxy, Andromeda, is about 2 million light years away, which means light travelling at 300,000 kilometres per second. From our point of view, takes 2 million years to travel from the Andromeda galaxy to us. So if you go away from the city lights and out into on a clear sky, and when there's no moon particularly, then you'll be able to see Andromeda if you've got some binoculars. And it's worth looking at, because the light entering your eye began its journey 2 million years ago, which is before we'd evolved on Earth. So that gives you a sense, and you can see that. You can just about see it with the naked eye, because it's big. It's a big galaxy, about 1 trillion stars. And it's actually, although it's very faint, it's bigger than a full moon on the sky, so it's a big thing. I think that's the best explanation of the scale, because you can just about, I think, get your head around that. But that's the nearest galaxy. So when you start talking about galaxies that we see, beautiful images with the Hubble Space Telescope or the JWST, for example, you're looking at things that are 50 million light years away, 300 million light years away for a thing called Stephan's Quintet and onward. And those, 300 million light years. And many of the galaxies we can see in photographs with like the James Webb, for example. Those things are so far away that the light began its journey before the Earth had formed. And that's incomprehensible, I think. So the answer is I can't explain the true scale of the universe or picture it. Is there life on Mars? Don't know, but it's certainly possible. And as we speak, there's we have several missions out there, but one of them is called Perseverance, which is a rover. And as we're speaking now, it's on the surface of Mars. It's taking samples. It's taken a lot of samples below the ground, and they're being packaged up for return to Earth in something that's called Mars Sample Return, because we think that it's possible that life existed on Mars or may still exist, because the conditions were right. It's certainly true that 4 billion years ago, almost certainly Mars was, it's like Earth. When life began on Earth, Mars was pretty much the same, with oceans and an atmosphere and so on. So it's entirely possible. And it would almost be surprising if it hadn't existed, because then it would tell us that even given the right conditions, then maybe there isn't a high probability that life begins or geology becomes biology or whatever the origin of life is. So, possible. Would teleportation work? It does. Maybe I should say a bit more. So it does, in the sense that, so it's been done with photons, for example, so particles of light. So you can do the experiment where you essentially, it's based on having two photons that are entangled, quantum entangled together. So the best way to describe that in about a second is that they behave as a single system, basically, but you can separate them. And then you can arrange for another one to come in, so it kind of interacts with this one, such that it ends up, this one over here, which could be a light year over there, ends up being in the same photon, essentially, as the one that came in, or in the same quantum state. So it's teleportation. And the incoming one gets destroyed in that process, or its state is changed. So yes, we do quantum teleportation in the lab, so it's real. The question then becomes, how big an object can you teleport? And I think in principle, there's no reason why you can't teleport anything, right? But it's very much in principle. What is a wormhole? Are they just science fiction? So no, the first time they came into physics was in 1930, I think it's 1935, in a paper by Einstein and Rosen. So they noticed that the description of the distortion of space-time in the vicinity of a star, which was discovered by Carl Schwarzschild in 1960, they discovered that if you take that description and you allow the star to collapse essentially into a black hole, and then you extend it infinitely into the past. So you remember, you say, well, let's imagine this black hole had always existed. So this universe in which this thing exists is an eternal universe. Then you get a wormhole. So a wormhole, the description of it is in the mathematics that Carl Schwarzschild discovered in 1916 for the distortion of space-time around a star. Literally, you have two universes, and they're linked by a wormhole. So one of them, it's a black hole, and the other bit is a white hole. So that's just formally in the mathematics. So that's what a wormhole is in Einstein's theory. That requires this black hole to have existed forever. So, and by the way, if the black hole's spinning, then you kind of get an infinite tower of wormholes. So the so-called Kerr black hole, this was discovered in the 1960s by Roy Kerr for a spinning black hole. The solution to that, if it's this eternal solution, is that you have an infinite number of universes connected inside the black hole by an infinite number of wormholes. So the modern work on trying to understand what happens to things that fall into black holes might suggest that there's a kind of a wormhole that connects the interior of the black hole to the exterior universe. And so the singularity looks like this kind of network, tangled web of wormholes of some description. I hedge my language because the language isn't really known yet, but it's one of the ideas, one of the possibilities suggested by the mathematics for the interior of a black hole. And the other thing, the final thing to say, is that you might have heard about there's something called ER equals EPR. So that's Einstein-Rosen, which is wormholes, equals EPR, which is Einstein-Podolsky and Rosen. And EPR was a question about quantum mechanics and what Einstein calls spooky action at a distance, where you can have entangled quantum particles, and somehow it seems that if you do something to this one, then there's in a very real sense, this one's affected by it, but not in a way that you can transfer information, but it's quantum entanglement. And there is a picture where you can picture that as the two particles being connected by wormholes, and that was suggested by Leonard Susskind and others a few years ago. That's called ER equals EPR. So wormholes are on the agenda in trying to understand what space and time are and how they behave. So they're not just science fiction. Would you like to be cryogenically frozen to experience the future? No, I think. I mean, first of all, we don't know how to do it, and we don't know if it's even possible to do. So you'd probably not survive. I wouldn't do it now. I wouldn't say, well, this is great, freeze my head. That if you're thinking of doing that, then don't, because we don't think it's going to work. But at the moment, but if it became possible, it's kind of interesting, isn't it? Because I could ask you the question, because it would mean that you essentially stop living now. So everybody that you know and everything that you know about is gone forever, and then you wake up like 500 years in the future. What's your favourite mind-blowing fact? I think there's a lot. I mean, from the area that I work in a bit in research is black holes, and I still think it's mind-blowing that according to Einstein's theory alone, time ends inside a black hole. So the singularity is correctly thought of as a moment in time and the end of time. Whether that's the case is it depends on understanding of quantum gravity that we don't have. The fact that black holes exist, I think, the gravitationally completely collapsed objects that distort space and time so much that even light can't escape once it crosses into the interior of the black hole, if indeed the black hole has an interior. We're even arguing about that these days. So I think black holes exist is my favourite fact. What's the scariest place in our solar system? The worst place for us, almost all of it, actually, beyond Earth, is horrible for us. It's almost like where is somewhere that isn't scary, because we couldn't exist. We couldn't exist anywhere unprotected, anywhere from about what 35,000 feet upwards or less, right, from the top of Everest upwards. We could, and then if you go underneath the water, right. So for us, if you go just a little bit down in the earth or a little bit up, there's a narrow band which is not scary for us, and everywhere else is horrible. Amongst the worst places are the sun, right? The sun's really not very nice. No, all of it. It's all absolutely terrible. apart from a thin band where we live, prove that the moon landings are real. Yeah, you just any photograph, look at any photograph taken by modern spacecraft, for example, which are not American spacecraft, if you want to be really conspiratorial about it. We have photographs of the landing sites with the stuff there. And I've met several of the people that worked on the moon. I've been very lucky to do so. And they are undoubtedly not bullshitters. And you've seen the video of Buzz Aldrin punching someone who said otherwise, and I fully supported him in that endeavour. How many galaxies are there? In the bit we can see of the universe, let's say 1 trillion, and you'll see different numbers because it's hard to measure actually. So we're making estimates based on little bits of the sky that we can observe. It's billions and billions and billions, to paraphrase Carl Sagan, and it's something like, you could say 300 billion, 500 billion, 1 trillion, even 2 trillion. So within a factor of 2, 3 or 4, we're not really sure. It's an estimate because you can't count them. It's an exercise for everybody who's listening. Count to 1 trillion and then come back to me when you've done it. That's a lot, right? Which physics conspiracy theory really riles me up, or you up? I think it is the flat Earth, because it's just bizarre. The moon landing stuff is bizarre enough, but the flat Earth thing requires almost everybody who's sensible in the world to be part of a conspiracy, and just a small number of people who, in my view, appear to be a bit odd, to be the only people who know the truth. So the idea that everybody who's kind of flies a plane or does science or does anything at all is like we've all the clever people have got together to invent something that for no reason at all is just, I don't know why that would be the case. Favourite scientist? Oh, it's so easy to say. It's so easy to say someone like Einstein, isn't it? I like scientists that have made a massive contribution that we haven't heard of. So one, which I was lecturing about the other day and talking about, is there's a scientist called Emmy Noether, and Noether Einstein described as one of the greatest mathematicians in history that many people have never heard of. And Emmy Noether, what she did was she showed the relationship between what we call symmetries of space. So the fact that the laws of nature are the same now and will be the same in 2 seconds' time. Right? So that's a symmetry in time. That's related to the conservation of energy. And she showed that the fact that if you do an experiment here and here, then you get the same outcome. The laws of nature are the same. Is related to something called the conservation of momentum, like the recoil of a rifle and so on. So that was brilliant. And so she's one of my favourite scientists because not many people have heard of her, but it's massively influential. What stops atoms mixing? Like, how do they know to mix with the right things? Well, we talk about chemistry, so they don't know how to do anything, but for example, if you have carbon, then it's got 4 electrons around it, which would like to pair up with other electrons. So hydrogen would be a good thing. That has 1 electron that would like to pair up as well. So you can stick 4 hydrogens onto the carbon and you make methane. How should we balance investment in space exploration with addressing problems on Earth? I was involved in a discussion yesterday, actually. It was really interesting. One of the experts in the space economy said to me that really we shouldn't think of the space economy as space. We should think of it as the economy. And so, because it's not far, right? It's just 100 miles up there. So it's about, we're in London now, so it's about the distance from London to Birmingham. If you go from London to Birmingham, but you go that way, you end up somewhere where you can do stuff that is useful, and it can produce economic growth. It can produce things like interesting drugs, for example, medicines and things which are not easy to build on Earth and so on. So you should think of space now not as a thing, a separate thing, but as a place where there's an opportunity to do stuff that benefits us all here on Earth, and that's the challenge.
And Brian, we've got about 10 minutes left, so I don't know if you want to choose some of your favourite questions.
Why don't I go really fast?
Go really fast? Oh, great.
All right, we've got 10 minutes left. I'm going to go really fast.
Really fast.
What's the most significant scientific discovery in history? I would say, oh, no, I'm never going to be able to do this. I would say that it's possible to describe the world rationally, which is the foundation of modern science. So you could say Newton's law of gravity is the first modern scientific theory, but it's that idea that you can describe the world rationally. Favourite creature on Earth? Human beings. Will AI destroy us all? No. Probably. How realistically could the world end tomorrow? The most realistic way that the world could end is that someone presses the nuclear button. Do you believe in a creator? No, but I am not the sort of person that gets very upset if people do, because we don't know how the universe began or even if the universe had a beginning. What do I believe is in Area 51? Having driven around Nevada, I would say sand. Do you prefer being a physicist or the keyboardist in Dream? A physicist? Definitely. Things have got better. Are we really from stars? Yes. So everything that isn't hydrogen in our bodies was made in the hearts of stars. Can infinity be measured? No, because it's infinite. Favourite alien from a film? Definitely Alien, because it was one of my favourite. I saw Alien, right, the film, the original film. I saw it at a school film club in 1979. So that just tells you how the world has changed, because I was 11 and they were like, this is good, we'll sit there and we'll show Alien to all the 11-year-olds. I fully approve of that. What scares you? I've said it before, but it's humans. It's the fact that we might not survive long enough to become effectively immortal as a civilization and become a multiplanetary interstellar species. What could happen to a human in space without a spacesuit? You'd die. What the hell is string theory? It's a theory of the underlying structure of the world, which is based on little things which are very small, which probably exist in 10 dimensions. Are you sick of talking about space? No. Biggest fear for the future of humanity, that we don't have one because of our own stupidity. Do we live in a simulation? It's possible. Don't know. Yeah, you want me to say more about that, didn't you? What's a solar storm and why is it dangerous to the Earth? Solar storms are potentially dangerous to the Earth. It's when the sun, essentially the magnetic field of the sun reconfigures itself such that stuff is ejected out into space. And it can be very damaging, not to the Earth really, but to our systems, power systems and so on, and satellites. So it causes trouble. What is something scientific that you could have died happy not knowing? Have you seen The Last of Us? Right. Because, you know, mushrooms take over ants. So, you know, I don't want the mushrooms to take over people. Is space travel ethical? Yes, I think it's more than that. It's essential, and we use it every day, of course, for GPS and so on. Which person would you least want to be trapped in a rocket with? There's quite a few. There you go. If you could choose one event in the universe's history to witness, what would it be? You know what? I'd like to see the origin of life on Earth, and that's weird because it's probably not an event, is it? But you know, I'd like to be able to go back and see how this all began.
Ingredients of life itself. You know, hydrogen is in our bodies. That was birthed in the Big Bang. And then we have carbon, nitrogen, oxygen, silicon, iron. Those elements did not come from the Big Bang. They came from stars. It's not just figuratively true, it's literally true that we are stardust.
You don't try and go into space and up to the moon and Mars and build space stations and so on so you can escape the Earth when you've messed it up. It is the opposite. The idea is that by going into space, building infrastructure, ultimately accessing resources in space, you save the Earth, because the Earth is the best place in the universe because we evolved on it and it's unique. I'm Brian Cox, and if you want my full title, I am Professor of Particle Physics at the University of Manchester and Royal Society Professor for Public Engagement in Science and Visiting Scholar at the Frick Institute in London, if you really want the full title. But I am here to answer questions from the Honesty Box. So the first question is, what is space? And that is a very good question. The 1 minute answer is, we don't know. So one of our theories is that space and time, for that matter. So I should say, back in 1905, Einstein realised that space and time are not separate, but they're woven together into something that's often called the fabric of the universe, or more technically, space-time. But we now suspect, or at least we have a theory, that space-time emerges from something deeper, which is just basically quantum entanglement. So we think that there is a description of our universe which is just bits of information, basically, or qubits to be more technical, quantum bits of information that are entangled together in some sort of network, so space and time don't exist in that network, and then space and time emerge from that deeper theory. This is cutting-edge physics, but it's one of the pictures that we have for what space and time might be. So there you go. What is space? It's also a thing that, you know, it's the distance between stuff that you throw. Whatever. Right. What is the best bit of evidence for alien life? We don't have any evidence for alien life, is the answer. So in the past, so we've landed missions on Mars, for example, the Viking missions in the 1970s, there was some suggestion that there might be some chemical reactions that looked a bit like life, and then it turned out that it probably wasn't, because it's very difficult to distinguish geology and chemistry from biology when you don't know what the kind of biology is that you're looking for. And so the answer is we don't have any evidence of alien life, of life beyond Earth, but we're looking. So that's the answer. And then everyone will whinge about that. We'll go, what about that flying saucer that landed in Chicago or something? And I'll say, I don't believe it did. What's going to wipe out humans first? If I was to guess, I would say humans. And that's not supposed to be a joke. I think that the biggest threat to our civilization is us. So we have complete control over that, but it might not help us, which says something about our stupidity. Beyond that, threats from space. So if a comet